Hi.
Hi, are you sure this course is just for 2499?
Yes, and you know this is the only course with this expertise across the world.
No way!
Yes way. Don't delay. Enroll now.
Geeks learning together.
Hi.
Hi, are you sure you can prepare for production?
Yes.
Hey, what do you mean by a self-paced course?
Well, the course material is available in the form of video lectures. And there are multiple practice problems that come along as well. So, you can access all of it anywhere, anytime. And they are available to you for lifetime.
No way!
Oh, yes way. Don't delay and enroll now.
Geeks learning together.
Hello everyone. Very good evening to everyone who has joined in this session. Just give me a confirmation that I am properly audible and visible, and then I will begin. Hello Rishit, how are you? I would request everyone, all the students who have currently joined me in this session, to kindly do a +1 in the chat box so that I could get to know your names, and at the same time, try to keep the session interactive. Okay, so yeah, thank you, Rishit. Give me a minute, I'm starting the session. Okay, let's wait for 1 or 2 more minutes while I'm sharing my screen so that others could also join. Okay, today we will be continuing with our series on recursion and backtracking. I would like to request everyone, those who have joined in this session, to kindly do a +1 in the chat box so that I could get to know your names. And at the same time, I would request you all to kindly keep the session interactive. Okay, so Rishit, I think that you were absent in the previous session. Uh, did you attend yesterday's session? Hello, Rishit. I suppose I am properly audible and visible. Okay. Yeah, you watched the recording. That's great, Rishit. Yesterday we discussed two problems. The name of the problem were subset sum 1 and 2. Okay. So today we will be discussing combination sum 1 and 2. Okay, so let's see, just a minute. Okay, so the name of this series is SDE Interviews Practice. Okay, and today the topic of our discussion will be recursion and backtracking. And more specifically, we will be discussing combination sum 1 and 2. let's see the screen. Okay, yeah. So I would request every one of you all to kindly do a plus one in the chat box if you are watching this recording, and that would help me know your names as well. Okay. Okay. So let us discuss them. The problem statement is combination sum one. Okay. So in this problem, you are given an array. Let's call the array as candidates. Okay, this is the name of the array. In this particular array, what you are given basically are distinct numbers. Now you have to return. Now you are also given a value called target. Now you have to return all possible subsets which you can form using this array candidates, given that you can pick any element as many times as possible. Okay. So you can pick any element as many times as possible, and you have to return all possible subsets. Okay. So let's see an example, and then I will tell you. Okay. So for example, let's say that you are given. Okay. Just a minute. Okay. So so let's say you are given your given array is contains 2, 3, 6, and 7. Okay. If this is your array and your target is 7, target is equal to 7. So then you can return something like 2, 2, 3, because 2 plus 2 plus 3 is equal to 7. You can also return just 7. This is also 7. So you will be returning these two arrays. Okay. And let's say and it is also given that you can pick the element any number of times. Okay, for example, if the array would be 1, 2, 3, and you are asked to form 6. Okay, so in that case you could have given 3, 3, 3 would also be have been an answer. 2, 2, 2 would also have been an answer. Then 1, 1, 1, 1, 1, 1 would also have been an answer. Okay, and after that 3 to 1 would also have been an answer. Okay, and apart from that 2 to 1 1 would also have been an answer. Okay, so these are the possibilities that you can basically get when the target is equal to 6. So you have to return all these subsets in the form of a vector of vector. Okay, so in this form. So how do you think will be the solution approach for this problem? Anyone, any ideas? Hello Mohammed, guys, how are you? Okay. Hmm. So Rishit, are you there? Tell me, what do you think will be an approach to solve this question? Um, so, Rishit, are you there? So, tell me, how do you think we will be able to solve this question? Okay, so let us continue then. So, basically, So now what we exactly we have to do is that apply the idea of recursion. Okay. So we will be apply the idea of recursion to solve this question. How exactly recursion will help us? Let us see then. Okay. So basically the strategy will be that for every element we have got two choices, whether to pick that element or do not pick that element. Okay. Do not pick that element. Okay. Now the best part about here is that we have infinite amount of quantities of every element. Okay, that means that every element is present in infinite amount of quantities. That means if you are picking that element, it doesn't mean that you no longer pick no longer can pick that element. In fact, if you are picking it, it means that you can repeatedly pick the same element so as to get the target sum. So if you are picking it, it means okay, you can still pick that element. But if you do not pick that element, you move to the next element. Okay, so this is the basic idea of the recursion that we will be following to solve this question. Okay, so let's say our initial as array was, we can just follow this one only, 2, 2, and 3. Okay, uh, or in fact, let us try to follow this one. One, like if you want to follow 1, 2, 2, 3. Okay, so the second example, my second example was specifically this one. 1, 2, 3, and we have been asked to form a target of equal to 6. Okay, so let's say 1, 2, 3, and we have to find a target equal to 6. Okay, so let's say in the first step of first recursion, what will happen? You're standing on the very first index. You have got two options, that whether you would like to pick that element or not. Okay, so let's say you pick that element. So now your sum becomes 1. Okay, and you are still on that here, on this element, and then you can either do not pick the element as well. So your sum will remain 0, and now you have come here. Okay, now if you're picking up the first element, you again have two choices, whether to pick the first element or move to the second element. Now let's say you pick the first element, so now your sum will become 2, and in this case you did not pick this first element and you go off to the second element. Okay, now here as well, what is happening here, you have already picked the first element. Now again you pick the first element, but you did not pick the first element, so you move to the second element. Okay, now once you move to the second element, you have two choices to whether to pick the first element or not. Okay, so let's say you pick the first element, so the sum will become 1 plus 2. Okay, in this case the sum is 1 plus 1. In this case the sum is still 0, so because you did not pick the element, now you're standing at 2. Okay, so now basically what is happening, you can either pick the element or do not pick the element. If you pick, the sum will become 2. If not, the sum will still remain 0. If you pick up the element, you've got two choices, whether to pick the element again, so the sum will become 2 plus 2, or you move to the next element. Okay, and if you pick 3, the sum will become 2 plus 3, or it will remain 2. Okay, so this is how the entire recursion tree will progress. Okay, you have always you have two choices, to pick the element or we do not pick the element. Okay, so Rishit, you are saying that for each number we try picking it 0 to n times such that it is less than the target. We use the difference as the target for the remaining element. Yes, exactly, Rishit. We will be using this idea only to solve this question. Okay, the idea will be based on whether to pick the element or not pick the element. Okay, so let us have a code that will help us understand this. Yeah, thank you, Rishit. So let's have a look at a code that will help us solve this question. Okay, so first of all, we need to declare a recursive function. So let me call that function as void f. The thing that this function will accept is the index, the present index on which we are particularly standing right now. Okay, so let's call this int. So index. Then we are also supposed to supply the target that we are trying to form, the sum, the final sum. Then we will be supplying a vector int that will contain basically the array. Okay, our array, and we will also supply another vector, answer, vector of int, which is basically my answer vector. This will store all my answer. And finally we will also supply another vector, let's say ds. This is a temporary vector that will help me keep track of all the solutions. Okay, so basically initially what we will do basically is that call this function. Okay, and initially we will call this function by supplying it with the value 0, because starting index will be 0. We will also give the target which we will receive from the input. We will also supply the sum, the array in which all the elements are present. Okay, make sure all the elements are unique in this case. Okay, distinct element. Okay, and you can pick any element infinite number of times. We will also supply an answer vector or vector which will store the answer, and an vector ds which will basically help you keep track of all the different types of subsets that you are forming in your recursion tree. Okay, now the first condition is that you pick the element. Okay, so if you are picking the element, in that case what will happen? What will be the condition to pick the element? So tell me. Yeah, I noticed that in your approach you build up from 0 to target, while I am going from target to 0. Both achieve the same purpose. Yes, exactly. Rishit, we can do that. Okay. Hmm. So just the base cases will become slightly different if you are going from back to first, or first to back, first to the end. Okay. So tell me, what condition? What is the most important condition that I need to check if I am picking the element? Okay. Okay, I just cannot pick the element. I have to check the condition before also. Okay, the condition that I have to check here is that if the array index, means the element that is present at that particular index, is less than or equal to target. Okay, so if this is getting satisfied, if this condition is getting satisfied, it means that I am allowed to choose the element. Okay, so after I basically what will I do? I will basically push back the element ARR of index. Okay, into my data structure. Okay, into my ds vector. Now what will happen here is that I have picked up this element, but the question says that every element is present infinite amount of time, infinite number of time. So in that case what will happen? I will recursively call the same function, but I will not increase my index. My index will remain at the same position because I am again allowed to choose that particular element so as to form my target. Okay, but one more thing will happen. The target will reduce. Okay, very important. Since we are picking the element means our target will reduce. Okay, so what will happen here? My target will become target minus ARR of IND. Okay, now since we are basically doing this check, it means that this will never become negative. Okay, that is the reason we had to do this check. If let's say we would not have done this check, in that case this number would have become negative. Okay, so that is something we do not want. So again we will supply all the things that are necessary for calling this function. Okay, now we have recursively called this function. Okay, now let us say that if the array index is not equal to is greater than or equal to the target, is greater than the target, it means that we cannot pick the element. Or in fact, let us see that if we choose not to pick the element, in that case what will happen? I will just recursively call this function, but with index plus 1. Okay, and I will supply all the same values: target and ARR and answer and ds. Okay, so this is the case where we are not picking the element. Okay, not picking the element. Got it? So is it clear? Now Rishit, tell me, there is one thing that I have missed in this code. Can you identify the mistake? There is one very minor mistake that I have missed in this code. Can you identify it? I have also not written the base case also, but first let me write the base case, then you will be able to identify it. Okay, so what will be the base case in this recursion? The base case will be that when we are reaching the very last index. Okay, so if the index is equal to the size of the array, that is ARR dot size. Okay, it means that we have reached the very last position of our this value. Okay, if we have reached the very last position, it means that if index is equal to n, means there are no more elements to pick. So in that particular case, there can be two possibilities: either you have achieved your target or you did not achieve your target. If you have achieved your target, so if target is equal to 0, okay, it means that you have achieved your target. In that case, what you will do, you will push back into the answer. Okay, you will push back into the answer. Okay, so now what will happen? You have a vector, you pick the first element. Okay, so let's say let me just show you to you in this way. So let's say that you have a vector. Okay, so this is your vector, and the first element of the vector is 1, 2, 3, 4, and 5. Okay, now you want to form a sum of 5. So what you do, basically you supply this vector to this function. This will recursively call for the first element. It will pick, so it will pick 1. Now the sum will become 1. Again it will recursively call, again it will pick 1. So it is now 1 1. Okay, again it will call, now the vector becomes 1 1 1. So this is a ds, this is a ds, this is a ds. This again calls a recursion, it will again become 1 1 1 1. I am just executing this step. Okay, and finally again 1 1 1 1 1. But at this point of time I see that target is equal to 0. Target is equal to 0 because 5 minus 5 is equal to 0. So what will happen? I will push this vector into my answer. This will go into my answer. Okay, so after that what is supposed to happen? Tell me something which I have missed in this code. Okay, uh, if target is equal to 0, then we push ds into the answer. Yes, Rishit, you are correct. So basically that particular is the base case. Now we missed popping out the out from the end of the vector ds when recursing back up to the recursion stack. Exactly. So I just showed you this example so as to make you understand that why this is possible. Because let's say at the end of the recursion we have got this particular data structure consisting of 5 ones. So target becomes 0, and we have successfully stored this in an answer vector. Now, so this is one particular recursion tree, and since we are passing this ds vector by reference, okay, we are passing it by reference. So it means that this particular ds vector is getting modified at every step of the recursion, and every time it is getting modified, if any of the recursion tree is modifying that the ds, it is still getting modified, right? So in that case, what I will do basically is that I have got one particular answer. Now I have to explore other possibilities also. So what will I do? I will just pop back the last element which I picked up. I will come back to this part, and then I will ask this recursion call to go to the next part. That is, do not pick this element. Then what will happen? Okay. So after that, means like, let's say if it do not pick that particular element, it will go to 2. Okay. So once it will go to 2, it realizes that it can no longer pick 2 because 4 plus 2 will be 6, which is greater than target. So it will again return. So once it will return, it will again pop back this function is basically, it will again pop back this one. So now we have finally reached here. So this will again call for the next part of the recursion, which is basically so it will try to pick up 2. So 3 plus 2 will be 5. So target is equal to 0. It will store 1 1 1 2 in the answer vector. And then finally what will happen? We come back here. We remove this one as well again. And finally we are left with this. So this will again step down here, right? So this is exactly what is happening here. We need to pop back the element. So as to that idea of popping back is basically called as backtracking. Okay. So once we are done with the recursion part, we are basically moving so that we take care of all possibilities which are possible using the recursion. Okay, so that is the reason we have to just apply a pop back operation as well. Okay, so the pop back operation will basically be fit here. We will be writing it here after this function call. Okay, so there is no space here. I'm just writing it here. We will do ds dot pop back. Okay, so we have to make sure we do this, right? So, Rishit, is it clear? Yeah. So, I would request everyone, the students who have joined presently, to kindly do a +1 in the chat box so that I could get to know your names as well. And let me just give you a small recap. So, presently we are having a session, having a series called Interview Practice Session for SDE Interviews, and the topic for this week is recursion and backtracking. So in this series, what happens is that I pick up important concepts which are very frequently asked in interviews, and we discuss one or two questions on a regular basis. So topic for this week is recursion and backtracking. Hmm. Yes, Rishit. The pop back is before the closing bracket. Okay. So, hmm. so because you will only pop back. See, so when you are picking the element, you pick the element. So it means that the second recursion call is not picking the element. Because once you are picking the element, you can basically have to pop back. Okay. So it basically means that inside that if statement, the pop back is also there. Okay. So this is about yeah. So also we are having so this next week we will be studying dynamic programming. So if you are attending this session, it will be extremely helpful for everyone. Apart from that, we also have a course called complete interview preparation. And in case if you are preparing for interviews, you can buy this course called complete interview preparation. This is an extremely well crafted course for studying and getting interview ready. Okay, so it contains all the important DSA questions and concepts that are very frequently asked in interviews. Okay, so it will most certainly help you. Okay, So let us move to the next part then. So I hope this part is clear with everyone. So now we let's move to the next part, and this part is basically combination sum 2. Okay. Yeah. Now we have to discuss the time complexity of the combination sum as well. So Rishit, tell me what will be the time complexity and the space complexity. So anyone? So anyone in the audience would like to tell what exactly will be the time complexity and the space complexity of the program? Time complexity will be 2 to the power n, where n is the value of target, and space complexity will be big O of n, where n is the value of the target. Yeah, okay. So tell me one thing: is the space complexity will be n because we have to return it in the form of a vector or vector. So we are returning multiple subsets, right? So multiple vectors. So I don't think the time complexity should be n. Think a little bit carefully. Okay. So where n is the value of the target. What do you think will be the answer? So your time complexity is correct. Time complexity is basically 2 to the power t. We have to also multiply with k. Okay. So why k? Because t is basically target. Okay. T is basically the target, and k will basically be the average length of every average length. Okay. So yes. So the time complexity will be 2 to the power t into k. And it will not be 2 to the power n. It will not be 2 to the power n because every element is present infinite number of times. Okay, so you can pick any element any number of times. And the space complexity will be k into x. Why k into x? Because k is the average length and x is the number of combinations. Average length and x is the number of combinations. Okay, so this is the space complexity. I hope everyone understood the time and space complexity of this question. One question is the output part of SC. Um, let's consider that. In fact, we are actually dealing. Since we are solving it, so let's consider it as a space complexity, because yes, actually we do not consider output as a space complexity because the actual logic doesn't require that space. It's just to output that output these the answer. Okay, but sometimes what happens, that you're already given a vector that you want to. But the question is asking you to basically modify that incoming vector only and print it out, okay, and not require any extra space. So in those type of question, if you are using that extra space, that particular adds to the space complexity. Okay, since it is not mentioned in any such cases, so we can consider that just outputting the answer doesn't require any extra space. Okay, but for this type of question, for this particular question, let's just mention it to the interview that yes, we will be requiring an extra space to store all the answer and then return it. Okay. Apart from that, only recursion stack space is the only thing that is needed, because the concept of this question is to apply recursion and solve the question. Okay. So, any more doubts? If everyone have understood this question, please do a +1 in the chat box so I can move to the next concept. Okay. So, yeah. So let us move to the let's move to the next question, and that will be a combination sum 2. Okay. So the name of this problem is combination sum 2. Now this problem is similar to the first problem, but we have certain changes. The first thing here is that duplicates element will be present. Okay, so duplicate elements will be present, and you have to find all possible unique unique combination in candidates where the candidate number sum to the target. Okay, such that sum is equal to target. Okay, for example, you are given an array, let's say 1 1 2 2 3, and you are asked to find a target is equal to, let's say, 7. So you can put 2 2 and 3 4 5 6 7. This is an answer. Hmm. And also each number can be only used once. Okay, so there are three conditions. The first is that duplicate element will be present. You are only asked to return the unique combinations only, and each number will be present exactly once. Okay, so for example, there are two twos. That is the reason I'm using two twos. Okay, so again I can use something like that: 1 1 2 3. Okay, this is a valid combination. Okay, so let's say if this 2 is equal to this 2, then I can also pick this 2 and make again 1 1 2 3, but this will basically be a duplicate of this one, so that is the reason I will not pick up that case. Okay, so it is asking us to return all the possible unique combinations. So tell me an idea, a brute force idea that will help you solve this question. Okay, anyone? Hello, Rishit. Tell me. So you can just basically do some little amount of modification to the previous code that we discussed, and then you can get the answer. Okay. So tell me, just two modifications, and you are actually done with the question. Okay. But that will be a brute force approach. And in this session today only, we will only be discussing the brute force approach. We will keep the optimized approach for the next session on tomorrow. Okay. First, remove duplicate elements from the input. No, no. It will give you wrong answer. Okay. because let's say that if you are removing the duplicate elements from the input, it means that you are left with 1, 2, and 3. So now you are asked to form a target of equal to 7. But see, we can also pick up the element 2, 2, and 3. So it means that 2 plus 2 equal to 4, 4 plus 3 equal to 7. So you are picking 2 twice because 2 is present 2 times. Okay. It just means that whatever you are returning should not contain duplicate elements. All possible subsets that you are returning, all possible sequences that you are returning should be unique in nature. Okay. So Rishit, is the concept clear? So, so in order to solve this problem, we just need to make two very important modifications to the previous problem, and we are done with this problem. But that will be a brute force approach because it will require some extra time. There is a slightly optimized approach that will help you, but we will discuss that tomorrow. Okay, because that will take around 20-25 minutes to discuss. So at each element you can pick it and not pick it. Okay. But the major change from the previous problem is that what is happening here is that in the previous problem you can pick any element infinite number of times, but in this question you are only required to pick it once. Okay. Regardless, after that choice we move to the next element. Yes, exactly, this is one modification that you can do. Okay, so since every element you can pick is only once, so either if you pick the element, move to the next element. If you do not pick the element, move to the next element. Okay, so that is one modification that you can do. So if you remember, in the previous code we had a function where we used to pass the value int. So when we are picking the element, we used to always pass index, the current index. But instead, in this case, we'll pass index plus 1 instead of index. So this is one modification. So let me write it here. So once when we will recursively call the function, we will be passing index plus 1. Okay. So the pick case will be we are passing this element and we are doing index plus 1. Okay. But this will take care of this condition. Now one more thing is present here, that all possible subsets that we are returning, or all possible vectors that we are returning, should be unique. So how do we take care of this? Tell me. So anyone? Yeah, the students who have joined new to the session. So we are having this session called practice session on SDE interviews. Every week we pick up a topic and we discuss few problems and important concepts which are very frequently appearing in interviews these days. And we also have a course called Complete Interview Preparation. And in case if you're preparing for your upcoming interviews, you can definitely check out that course. So it contains all the it contains all the important concepts, and in a very much well crafted and structured manner, which will certainly help you prepare for your interviews. The link is in the description. Okay. So Rishit, tell me. Okay, so basically, what exactly is happening here is that think of a data structure that basically will help you remove all the duplicate elements. So, do you know any data structure that will basically help you remove the duplicate elements? In fact, it is a set. So, what we exactly we were doing here is that we were using a vector of vector int answer, right? So, we were using a vector of vector to store all possible answer, but instead we will be using a set. So, we'll be using a set of vectors. Okay, a set of vectors. and this will be our answer. So we will store all the answer here, but the question asks us that we have to return a vector only. So after this set is prepared, we will just copy all our values from this set into another vector, which we will return to our caller function. Okay, so all we have to do is use set. So the time complexity and the space complexity will be exactly same to the previous concept, previous problem, but in the space complexity will actually increase here, and the time complexity will remain same since it is 2 to the power n concept only. Okay, but the thing here is that we have to optimize this. Okay, so the optimized version of this problem we'll be discussing tomorrow because it's a much bigger problem and it will take some time. Okay, so I hope you all understood this suboptimal approach, and whenever you are actually can we store the results in a set to eliminate the duplicates? Yes, exactly, Rishit. That is exactly what I told. Sorry, I read your comment a bit late. Okay, so yeah, you are correct. Okay, so this is a suboptimal approach, but doesn't matter. Whenever you are discussing this to the interviewer, you will be whenever the interviewer is asking you, you will be basically telling you this concept only in the beginning, and then you will go to the optimized approach. Okay, so let's pause our session for the session today till here, and then we will be again back tomorrow for the same session. Okay, okay then. Um, yeah, bye bye then. See you tomorrow then. Okay.